Hey there and welcome. By the end of this lesson, we will be able to graph lines using the slope-intercept equation. Let's go ahead and get started. So the first thing we need to talk about is what is slope? Slope is the ratio of vertical change, which we call the rise, to the horizontal change, which we call the run. So basically how steep a line is. So let's look at the actual slope-intercept equation, which is y equals mx plus b. And each part of this equation has something to it. So it's going to be a lot and it's going to be fast. But let's get through this. So our y is the y coordinate. So in our x comma y, it's the y portion of it. It's the part that moves our graph up and down. And it's our dependent variable, which means that the number that we get for that is completely dependent on everything else. What our x is, our m is, and our b. And it's also known as the output. So we're going to have an input and we calculate all the things. The output is the answer that we get for it, which is our y. M has a lot of parts to it. It's called the slope. It is that ratio of rise to run, our rise over run. We also call it the change in y over the change in x, which is what those little triangles are. It's the Greek symbol for change. And just remember that change really just means subtraction. So if we have y2 minus y1 over x2 minus x1, all three of those things are the same exact thing. Our rise over run, change in y over change in x, y2 minus y1 over x2 minus x1, they are all three the same exact thing. How you use it is really just dependent on the format that you are given for finding slope. But I want you to also realize that these are all fractions. Slope is mostly used in terms of fractions. So keep that in mind. The steepness of slope, the steepness of our m value, comes from when m is bigger than 1. And that doesn't look at the positive values or the negative values, it just looks at the number itself. If the number itself is bigger than 1, we're going to say that it's steep. And if that number is something between 0 and 1, we're going to say that it's shallow. Again, we're not looking at the positive or the negative. We're just looking at the number itself and where it falls. The next part is x, which is the x portion of our xy coordinate. It's what moves our graph to the left and to the right. It's our independent variable, also known as the input. So when we're finding slope and we're doing all of these graphing things and we're putting it on a graph, we're plugging something in for x. We're calculating everything to determine the y value. And then our last part is b, which is also known as the y-intercept. We call it the beginning point. And because it's a point, it's going to always be 0, comma b, whatever your b value is. It always starts with a 0 because it's on the y-axis. That's why it's a y-intercept. It's where it crosses the y-axis. In order to cross the y-axis, our x value, the part that moves it left and right, has to be at 0. So this is the slope-intercept equation. Let's actually use it. But before we can use it, we have to talk about proportional versus non-proportional graphs. If your graph is proportional, your beginning point, which remember is your y-intercept, is going to be at 0, 0. It's going to go straight through that origin. If your graph is not proportional, then your y-intercept is going to be something other than 0, 0. Just remember that that x value has to be 0 no matter what. Otherwise, it's not the y-intercept. So we could have it at 0, 15, 0, negative 12, 0, 475. Any of those would make the graph not proportional. So let's actually look at some equations and identify the information. So this first one here, we have y equals negative 4x minus 7. The first thing we're going to do is look at our slope, which is negative 4 or negative 4 over 1. Remember that I said earlier that we write slope as fractions a lot, and it makes it easier when we go to actually graph. But if you leave it as negative 4, totally acceptable. If you write it as negative 4 over 1, it's the exact same thing, because remember that negative 4 divided by 1 is still just negative 4. The y-intercept is going to be at 0, negative 7. We get it from that second part of the graph, the b value. Please remember to keep your signs. If it starts off as a negative, it's got to be negative. If it's a plus, it's got to be positive. The direction that our graph is going to be negative, and we figure this out from the slope. So when we say that it's going in a negative direction, we're saying that it's going at a downhill section, right? We look from left to right, our line is going downwards. To figure out if it's steep or shallow, remember I said we're going to look at our slope in just the number. I don't care if that number is positive or negative. That's just going to tell me if I'm going up the hill or down the hill. But how steep is that hill is just the number itself. Remember, if it's steep, that m value is going to be something bigger than 1. 4 is definitely bigger than 1, so this is steep. This is like saying you go up 4 feet when you take 1 step. So just imagine that you skip 4 stairs when you're climbing up the stairs, right? You go up 4 feet in 1 step, right? Like that's what that's saying. That's really steep. That is a hill that Miss Simi does not want to climb. All right, and then proportional or non-proportional. Remember, we have to look at our y-intercept value for this, our b value. If it's not at 0, 0, it is non-proportional. So let's look at another one. So this time we have y equals 1/3 x plus 4. Our slope this time is 1/3. Our y-intercept is at 0, 4. The direction this time is positive, so it's going in an upwards direction. We're going up the hill. But this time that hill is going to be shallow. So in order for us to go up 1 foot, it's going to take us 3 steps to get there. So it's not very steep, right? It's pretty shallow. And in terms of proportional or non-proportional, again, we are not at 0, 0, so it's non-proportional. Let's look at one more. This time we have y equals -3/5 x, and our slope is -3/5. Now you'll notice that this time we don't have a plus b. There's no +4 or -7 like we had in the last 2 examples. If we don't have anything, it's +0 because you don't have to show it. So our y-intercept this time is at 0, 0. The direction for this one is negative. Our slope is negative, so we're going downhill. In terms of steep or shallow, 3/5 is in between 0 and 1, so it's going to be shallow. And proportional or non-proportional, well, this time our y-intercept is 0, 0, so it's proportional. And that's all the information that we can get from this equation. It's quite a bit, and it's really helpful for later on. So now let's graph. We're going to graph that y equals -4x minus 7. And when we graph it, we need to choose values for x. And we can choose any values that we want. There is no rule that says what numbers you have to choose for your table of values. General rule of thumb that we like to use are 2 negatives, 2 positives, and 0. So the most common numbers that you're going to see are going to be -2 for a start. So when x is -2, you're going to substitute it back into the original equation and figure out what that answer gives us. So we have -4 times -2, which is +8, minus 7. 8 minus 7 is a +1. So let's actually graph that point. When we graph it, we're going to go to the left 2 for x and then up 1 for y, and so that point is going to be right there. Then we're going to check another point. I'm going to go with -1. Again, this is my choice because, remember, I have to graph it. I want numbers that are going to be small and in the same area. So I've got -4 times -1, which is +4, minus 7 gives me -3. So when I graph this one, I'm going to go to the left 1 and down 3. 0 is always a fantastic number to check, and remember, it's your beginning point. It is always great to start with that beginning point. I plug in 0 where the x value should be, and I got that -4 times 0 is 0, minus 7 gives me -7. But if you look at the graph, it doesn't go down to -7. That's okay, just make a bigger graph. I've now made a bigger graph, and I've graphed that point at 0, 7. Please note, this dot is on the line. It's on the axis. That's okay. It's supposed to be there. It's still a spot. 0 is still a number. Our next point is at 1. I'm choosing 1 for my x value. So -4 times 1 is -4, minus 7 is -11. So my next point is at 1, -11. And the last point that I'm going to choose is +2. -4 times +2 is -8, minus 7 is -15. So my next point goes at 2, -15. Now the super important part to remember is that this is a continuous graph. We personally chose the values that we have for x, but that does not mean that those are the only values for x that you could choose. We could have said that x was -2.365, We could have said that x was 274. We could say that x is any number that we want. These are the numbers that we chose, but they're not the only numbers possible. So we need to connect all of our dots and draw arrows to signify that this line continues both ways forever. We've only stopped the graph because this is what we stopped it at. But we definitely have far more options that we could plug in if we so wished. You have to make sure you have those arrows. They're super, super important. You have to connect the dots because that line means that every single part of that line is a point that exists in this equation. So keep that in mind. Now, that was actually quite a bit of work. We can make that faster, so let's do that. So let's look at y equals 1/3 x plus 4. We need to remember that our slope for this problem was 1/3, and our beginning point was at 0, 4. When we look at our graph, the first part that we're going to look at is our beginning point. That's why we begin at that point. So 0, 4. I've got my dot right here at 0, 4. Now remember that we said that our slope was rise over run. Super important wording. Please remember, you have to rise up out of your seat before you can run down the hallway to your next class. When we use rise over run, we're going to say that we're going to rise up 1 because that was the value of our rise. And we are going to run 3 places to the right. We're moving up and to the right because they're both positive numbers. And so when we move up 1 line and to the right 3 lines, that gives us our next point at 3, 5. We can do it again. We can go up 1 and to the right 3, and that gives us our next point at 6, 6. We can also go the opposite direction. So instead of going up and to the right, I can go down and to the left. Down 1, left 3 gets me to the same point that we just had. If I go down 1 and left 3 again, it gets me back to that beginning point. If I go down 1 and left 3 one more time, that gets me to a new point. So you don't always have to make your graph bigger. Sometimes you just need to go in the opposite direction based on what you have. But again, we have to connect all of our dots and draw our arrows. And now we've graphed. It's a lot faster and completely works. But if you are that person that needs to use that table of values, absolutely use the table of values. If you forget how to do this later on, always use the table of values. It will work for every single graph that you make from here on out. Every single time. Let's look at one more. If we've got that y equals -3/5 x, remember that our slope is -3/5 and our beginning point was at 0, 0. So when we go to graph it, I'm going to start my first point at 0, 0. I'm starting at the origin. Remember, this one was proportional. Now, this time I'm going to go down 3 lines and to the right 5 lines. This is what gives me that negative slope. That negative only goes to one of those 2 numbers, either your numerator or your denominator. For this one, I made it the numerator, which is why it's going down. Right is still a positive direction. I only have 1 negative in this fraction. I can only go 1 negative direction. So I'm going down 3 to the right 5 to get me my next point. And then I'm going to go the opposite way because I don't want to continue my graph on to the right. So this time I'm going to go up 3 and left 5. This time I've made the denominator that negative because going left is heading in that negative direction. So I go up 3 lines, I go left 5 lines, that gets me my next point. Don't forget to connect your dots and make your arrows. And that's all that we've got. So what we learned today were the components of the slope-intercept equation, how to graph slope-intercept using a table, and how to graph it using just the equation. I know it was super fast and it's a lot of information, but you've got this. So until next time, I'll see you later. Love you, bye.